Independent Dialogue, Monitoring and Evaluation for Food Systems Transformation. I'm Greg Sixt, Director of the Alliance for Food and Climate Systems Transformation and Research Manager for Food and Climate Systems at MIT's Abdul Latif Jameel Water and Food Systems Lab, also known as JWAFS. The Alliance is convened and coordinated by MIT JWAFS and represents a cooperative global effort of 16 research institutions and a growing network of collaborating stakeholder organizations to strategically catalyze research to create a more just, sustainable, resilient, and nutritious food system. These stakeholder collaborators include World Business Council for Sustainable Development, OECD, World Wildlife Fund, and Just Rural Transition. Our global network allows us to address some of the most critical knowledge gaps in the food systems climate nexus across a variety of scales and geographies. Our approach is to work with stakeholders throughout the process of identifying systemic barriers and opportunities for transformation, filling knowledge gaps, and scaling solutions. This Science Days side event represents the second public event of the Alliance and is co-hosted by Alliance members, University of Pretoria and World Business Council for Sustainable Development. Last week, we hosted an independent dialogue focused on addressing a similar theme with a more stakeholder-oriented focus. Today, we're looking to dig deeper into the technical aspects of monitoring and evaluation for food systems transformation to identify priorities around the data needed for this. The 2021 UN Food Systems Summit is part of the Decade of Action to achieve Sustainable Development Goals by 2030. We currently don't have a complete picture of how to measure success in transforming complex and interrelated food systems towards greater sustainability and climate resilience. We hope that today's dialogue, with its panel of distinguished experts, followed by the breakout sessions in which you will participate, will provide valuable input for the Food Systems Summit process with regard to how we measure systems change. But first, I'd like to introduce our keynote speaker. His address was pre-recorded, Dr. Maximo Torero Cullen. Maximo is the chief economist for the UN Food and Agriculture Organization. He joined FAO in January 2019 as assistant director of the Economic and Social Development Department. Prior to joining FAO, he was the World Bank Executive Director for Argentina, Bolivia, Chile, Paraguay, Peru, and Uruguay. And before the bank, Mr. Torero led the Division of Markets, Trade, and Institutions at the International Food Policy Research Institute. His major work lies mostly in analyzing poverty, inequality, the importance of geography and assets in explaining poverty, and in policies oriented towards poverty alleviation based on the role of infrastructure, institutions, and on how technological breakthroughs can improve the welfare of households and small farmers. His experience encompasses Latin America, Sub-Saharan Africa, and Asia. Dr. Torero, a national of Peru, holds a PhD and master's degree in economics from the University of California, Los Angeles, and a bachelor's degree in economics from the University of Pacific, Lima, Peru. This video will start in just a moment.
It's a real pleasure to be with you today. My goal today is to try to bring some ideas on how we can measure and trying to track and monitor the agri-food system transformation that we're trying to look at and we're trying to bring as a result of the pre-summit and the Food System Summit. Let me share my screen with my presentation. So first, when we look at the agri-food systems, we need to understand that it's a complex and are characterized by multiple interactions, trade-offs, and feedback mechanisms. The food systems interact with many other systems. Tracking the complexity of agri-food systems require the use of a comprehensive set of metrics so to set the boundaries and define typology of a food systems. It requires also having very clear goals and also looking at sustainable transformation and to measure and monitor the performance of the impacts of policies and interventions on improving the sustainability of food systems. Here we see how they interact with the health systems, with the ecology and climate systems, with the science and innovation systems, and economic and governance systems. Now, all these interactions normally are not measured. Normally we focus on silos in each of the different elements, but we don't look at interactions, and that is the way in which we can have a systemic approach to what we are trying to analyze. Several initiatives in recent years, like the food system dashboard that we're working together with GAIN, are trying to capture and improve understanding of key information for complex systems and help countries in tracking progress and impact policies, other interventions, and transformation of food systems. But one thing which is missing in this type of systems is how these different elements interact with each other, what we call the trade-offs or synergies behind the food system transformation. Also, we are trying to improve the understanding and build up composite indicators or indices like sectoral level food agricultural benchmark, developed by the World Bank Alliance, World Benchmarking Alliance, the national level, the Canadian National Index on Agri-Food Performance, and a global level like the Global Map for Food Systems and Sustainability. But we really need to understand these systemic interactions, what we call the trade-offs. The world today is marked by interlinkages with positive synergies, but also by negative interactions and externalities that imply trade-offs between sectoral, local, regional, global, and temporal dimension. So food systems in many countries are facing issues and complexity within the agri-food sector, and food insecurity, the triple burden of malnutrition, the impact of climate change. And for example, any activity that I do to achieve the goal of eliminating undernourishment in the world will require potential synergies and trade-offs, mostly trade-offs in the sense that if I want to intensify the production, that could affect my land, my water, my soil, my biodiversity, create more emissions at the same time of achieving my goal. So how we bring this together and how we can measure this pattern of trade-offs within SDG 1, 2, and the natural resources. That's the major goal, and I think where the complexity of trying to monitor food systems come. So going beyond indicators is central. The dashboards can give us an idea of the status. It's like a photograph, an static photograph, but doesn't give an idea of interrelationships. We need to understand the interlinkages between outcomes, and we need to understand the causal pathways to be able to achieve this. So foresight and trade-off analysis can help identify the most appropriate pathways to address the three sustainable dimensions. Dimensions on income, dimensions on the environment, and the dimension, of course, on social dimensions. Now, to do this, we need to find ways in which we can measure this. And what we have been trying to do as part of the Food Systems Summit is to try to develop a modeling structure that will allow us to measure these trade-offs and synergies. Why they are so important? Because we look at the photograph today, the current food system, the choice of indicators today, and the data available. Then we try to understand what will be a transformative process that will allow us to achieve, for example, the SDGs in 2030. And that is a transformed agri-food system that we are aiming to. But that requires changing of incentives and changes of income distribution and land distribution, for example. And that will bring important trade-offs that we need to take into consideration. That is the interlinkages. So in this graph, what I'm trying to show is how we bring the social, the environment, and the economic dimensions, the three dimensions of sustainability and also risk, and how achieving the ultimate goal, which in our case is achieving SDG 2, for example, or access to healthy diets for all, will create some trade-offs and potentially some synergies. And this is interlinked with One Health, with zoonotic diseases, and is interlinked to all the other dimensionalities. Measuring those trade-offs is the central objective that you're trying to do. So it's not only achieving the goal, but how you achieve the goal and what are the level of trade-offs that you generate and how you can minimize those so that the pathway that you choose is the best possible pathway. For example, we can have objective functions of access to sufficient calories, access to healthy diets for all, adequate incomes for all to access healthy diets, or sustainable environment. If we want at the end to have one objective function, which is healthy diets for all, with the constraint of sustainable environment, then we need to look at land, water, soil, energy, biodiversity, and greenhouse gas emissions. And that's the objective function that we try to maximize. And for that, we need to understand the different trade-offs between them. And the trade-offs will come in different SDGs. It will come in water, SDG 6, in energy, SDG 8, land, goal 15, biodiversity, SDG 14 and 15, emissions, goal 13, inequalities, SDG 1 and 10, health, SDG 3, and gender, for example. So once we have that conceptual framework and we have this modeling capacity to be able to measure those trade-offs, then we can start talking about how to monitor the agri-food system, because it's not only achieving the objective function, access to healthy diets for all, but also achieving the pathway to achieve that objective functions, minimizing those trade-offs. Now, there are two other dimensions that we need to take into consideration to be able to prioritize what are the best options and what are the best mechanisms. So we need to have a multi-metric to common currency comparison, so how to identify monetary equivalents so that we can compare them. And then we have to look at the environment performance, the social performance, for example, and the economic performance, and trying to use this metric to be able to make them comparable so that we can end with a common dollar value of following one pathway versus following another pathway. That's the only way we can compare. So that's the first element, how we bring this multidimensionality of the trade-offs in one common metric. The second element is working in a time dimension, because some of the actions that I could make like, for example, investment in research and development compared to intensification of production, they have different time paths. Research and development will take longer to bring the return relative to what it will be the case of intensification of agriculture. So for that, we need to bring it to the present value to be able to make them comparable and therefore to be able to measure the performance of each of them. And that requires, for example, a time discount to be incorporated into this process of decision. So again, both the common metric to be able to compare and taking into account the time dimensionality will allow us at the end to be able to compare different options and different pathways to achieve that goal. That's exactly what we are aiming in the case of the periodization in a multidimensional space for the Food System Summit. Why? Because we will have different game changers and they will have different impacts. The objective functions will be reduction of undernourishment, but we will have reduction of unaffordability of healthy diets also, and other types of dimensions that we want to take into account. And that metric, common metric and common present value of those trade-offs will allow us to choose between the different options. So this is for me the biggest challenge that I want to bring up, and I think is the way forward that we need to find and ways in which we can change what we're doing today. Thank you very much, and it was a pleasure to be with you today, and I hope this helps to start the discussion. Thank you.
I think that was actually a perfect primer for today's discussion. So even though he's not here, I'd like to thank Maximo for the keynote address. We're going to move on now to our panel discussion, applying monitoring and evaluation to food systems work. I'd like to introduce Dr. Cheryl Hendricks, who will moderate the panel discussion. Cheryl's professor and head of the University of Pretoria's Department of Agricultural Economics, Extension and Rural Development. She's a food security policy expert with extensive experience in policy analysis and program design. Her research and teaching focuses on food security and nutrition policy analysis and monitoring and evaluation of food security at the household, national, and global information systems level. She's actively engaged in the high-level global food security policy think tanks and panels, and she's a member of the Montpellier Malabo panel and the science group for the 2021 World Food Systems Summit. Cheryl?
Thank you so much, Greg, and thank you. Good afternoon, colleagues, and thank you for joining us for this very interesting discussion. Listening to Maximo brought me back to the moment I first met him in 2006, where him and his colleague Usman Badiani were talking about the convergence agenda. And I have to admit, as a relatively green academic, it took me a little bit of time to work out exactly what they were talking about. But now we have the whole world talking around the convergence agenda around food, nutrition, safety, and inequalities linking with production. So I think we've come far in the discussion. It's my delight to be able to chair this panel of 4 distinguished speakers today. So we're going to get started. I'm going to ask each panelist to please introduce your domain. All of you work in transdisciplinary domains, and to explain how you use M&E in your particular field of interest and why it's important. And then we'll go around the second round of conversations to dig a little bit deeper around the gaps. So first of all, it's my pleasure to introduce my boss, Professor Barend Erasmus, who is his research, he's the Dean of the Faculty of Natural and Agricultural Sciences at the University of Pretoria. He's passionate about transdisciplinary research, and we're very privileged to have such leadership to push the boundaries of thinking. He's conducted research on climate change impacts on biodiversity and system change, with looking particularly at long-term land change cover and the sustainability of rural landscapes. Thank you. Over to you for your introductory comments.
Thank you very much, Cheryl. It's nice to be in a meeting where I'm not wearing my Dean's management hat, and I actually get back to being a little bit of a scientist again. So thank you very much for the opportunity. Nice to engage with this community at an arm's length. I've been kept abreast of what's been happening via Cheryl, so it's really nice to engage here. I'll be quite brief because I think there's lots of opinions and lots of expertise in this forum that I think we'd like to get to. Thinking about biodiversity and climate change and how do we monitor and evaluate the impacts of climate change and biodiversity, the first thing that comes to mind is that tracking biodiversity by itself and tracking changes in climate by itself, both of those are quite tricky. Once we start looking at the interaction with them, then it becomes really complex, not just complicated. For any of these complex systems, our understanding of the interdependence of the different individual components determine to a large extent what we monitor and evaluate. So obviously not all components interact with each other equally, and some of them are more important than others, and different literatures call them tipping points or trim tabs or points of intervention that have got a disproportionately large impact on the system. And if you don't understand or don't have enough disciplinary knowledge to understand where these are within your particular system, then your monitoring evaluation will be monitoring and evaluating maybe the long, slow variables, but the quick, short ones are the ones that are going to catch you. Good examples here are long-term drying trends in African savannas. They're important. We can see them with reasonable accuracy from satellite, but the things that really change on where kind of in the landscape is when you have the concomitant fires associated with drought, and then long-term drought, big fires, and that's the real transformative force on that landscape. So as an example. So what do we measure? So when we think about these systems, first thing is about the disciplinary knowledge, understanding the tipping points. And then there's a number of ways of thinking about what you need to monitor. The first one is around broad scale, and this is typically remotely sensed data for various proxies of biodiversity, structure, carbon, cover, and a number of others. And that gives you some measure of change, but you don't get the full picture if you don't have a scale-specific monitoring and evaluation to understand that. And the finer you drill into the details of the spatial scale, the less you, the more you need the disciplinary knowledge to make sense of that. So the first one is scale. My last point here is around which variables to choose. So I think understanding, sorry, I've just lost my spot here with my note. So not just understanding the tipping points, but also understanding rates of change. So in many cases, it's difficult to measure any particular variable with a high degree of precision, especially over large scales. But if you understand the rate of change, or if you understand the variability or changes in the variability, and there's a good body of literature that says increases in variability precipitates a tipping point of some sorts. Not true everywhere, but there's some good literature there. So looking at the rates of change, the variability and the changes in variability has been quite useful to understand when there's an imminent tipping point, and to understand to inform monitoring and evaluation in a proactive manner. So that's kind of a broad brush overview of obviously not exhaustive of elements in M&E in this particular domain that I've bumped into. So thank you very much, Cheryl.
Thank you. You really bring the complexity. So you're talking about the need for deep but broad knowledge of each of the different components. And maybe we can pick up on our next round of questions as to how you convince others around the table of the importance of the indicators in your particular domain. Thank you so much. Nicole, can I move to you? So Nicole Taschereau-Blackstone is an assistant professor in the Division of Agriculture, Food and Environment at the Friedman School of Nutrition Science and Policy at Tufts University in the US. She has been focusing on industrial ecology, nutrition, and social science methods. And I know from the brief interaction I've had with Nicole in establishing the alliance and the underpinning framework, that she has some of the deep knowledge and also the capacity to look broadly. So Nicole, would you like to give us your introductory remarks?
Sure. Thank you so much, Cheryl. And it's a pleasure to be here with you all today. In my work, Cheryl mentioned I have an interdisciplinary toolbox, and most of my research takes a life cycle or a supply chain perspective. And most of my work is also focused on sort of US specific systems and policies. So I'm used to sort of working in a high income country context, but some of the things I'll share are applicable across income levels, different domains, et cetera. I don't do traditional M&E work as we may think about it in the realm of, say, monitoring and evaluation for food security status. In the space that I work in, we use a lot of modeling, as Maximo was discussing, to estimate environmental impacts or social risks in supply chains instead of going out and measuring them. This is in part because in some cases it's actually impossible to measure the construct that we are estimating, and in other cases it's because it would be very expensive or infeasible to actually go out and do the field work to measure at the scale that we need to. A different kind of lens I bring to this work is that because I think about these issues in terms of supply chains, so many of our supply chains are highly globalized. So we're not just thinking about the status of indicators in one geography. We're thinking about the status of different indicators in a supply chain that cuts across many different geographies. And so that's an added layer of complexity when we think about how we bring data together and think about trade-offs, et cetera. So thinking about how I use kind of the M&E type tools in my field to track progress against targets. So I'll give a couple examples, one in the environmental space and one in the social sustainability space. So in the environmental space, I use a tool called life cycle assessment, where we model or estimate the environmental performance of different products, diets, policies, supply chains, you name it. And that thinking about climate change and climate related impacts, we can do an LCA of a system, and then increasingly thinking about targets in this space and important actors on climate action. Increasingly, companies and other actors are setting what are called science-based targets. And those targets would be sort of indexed to the Paris Agreement, so that companies or organizations are actually setting their internal targets toward kind of what they should be accountable to help achieve their sort of fraction of mitigation for the Paris Agreement. So this is actually, I think it's a really interesting model to be thinking about for other sustainability indicators as well. You know, how do we set those targets? How do we ensure equitable accountability across stakeholders in that space? But that's one area where I actually think the indicators are pretty well developed and the targets are pretty well developed as well. And there's a lot of room for just adoption and improvement over time. In the social space, there is a much larger black box of available indicators and data in food systems. So I do work on labor exploitation and labor conditions in food systems. And one of the indicators that I have been working on recently is forced labor, which is one of the most severe human rights violations that exists in the world today. And we actually have very little data globally, at the country level, at the commodity level, you sort of name it, on occurrences of forced labor in food supply chains and agriculture and food processing in different segments of the food system. And so my team is actually, you know, using some novel tools to develop new data sets and try to estimate risk of forced labor across a diverse set of commodities that the US public consumes. So in some cases, we actually need to create the data from scratch because it just doesn't exist. We can't just aggregate a bunch of secondary data and call it a day. So there's actually a lot of work that needs to be done on the social side. And I'll just say, thinking about, that I'll stop there and we can come back to that.
Okay, so you bring into focus the disparities between the amount of data that is available in the different domains. Great, a gap we can pick up on later. Thank you so much. Shailandra, can I go on to you? Shailandra Kumar is a principal scientist for innovation systems for the drylands at ICRISAT. He's carried out extensive research looking at the economics of rain-fed farming systems, whole farming models to support decision-making at the household and regional level, and looking at the trade-offs that Maximo was talking about in terms of the climate smart interventions. So as a systems scientist, Shailendra, what would you say is the contribution of M&E in your domain, and how would you track progress in your field? Thank you. Sorry, you're muted.
Thank you, Cheryl. It's nice to be here, and I just try to link with what others have spoken, and especially taking from the keynote. So our team, which is truly a transdisciplinary team at ICRISAT, where I'm part of it, is focus of the work at International Crop Research Institute for semi-arid tropics is that how to enable system transformation or the food system transformation, and through science-based, inclusive and sustainable solutions, especially focusing in the dry areas of semi-arid tropics, to make progress toward the food system transformation, which aspires to achieve sustainable diets, as we see, and health for all, and within the planetary boundaries through inclusive processes. It's important that to monitor and track both, I would say, when I would not be detailing on indicators, but the key drivers of the agri-food systems transformation. For example, the carbon or natural resource footprints across the value chain stages, but also like other hazardous like plastics or maybe the chemicals which are impacting the whole value chain of the food systems. But at the same time, it's also important to look at the outcome indicators like access to nutritious and diverse food for all, food waste, and how the current trends of commercialization are impacting the consumption behavior. But also it's very important when we look at the dry areas to understand the level of risk, both at the supply side and the consumption side of the food system, and also looking at the linkages with the cross sectors. So our team, we use an ex-ante assessment and system modeling tool, and also the trade-off analysis to understand the vulnerability and risk across different stages of value chains. So I would admit that until recently, the focus has been more on the production, up to the production stage, but now we are focusing more on the across the different value chain stages. But we also use foresight analysis to understand the future impact of innovations and policy. That's again very important, and it can be again made more robust as we have more information on different indications. Another key method which ICRISAT has been promoting, ICRISAT has set up a longitudinal studies on the farm household since 1975. Sure. And that helped track some of the segments of the food system, I would say, because it was again, though the consumption, production and technology at the farm systems level, but in future appropriately framed and wider longitudinal studies using the digital tools and all could be very effective tools to track the progress of farming food system transformation. Another tool which I would mention is that mapping the personal and external food environment, and to understand how various policies and interventions are impacting availability, accessibility, affordability, even desirability and quality of food across the people people as a part of the system. And through case studies, we also use the dynamic and economic modeling to understand the causal mechanism and feedback loops, because the relationships are not always straight, but how it is impacting, what are the feedback loops. So that helps us understand the real impact of various, and also looking at tools to understand the multidimensional impact of different interventions. And the recent past, we have also, our team has started working with the agri-tech startup companies, especially focusing on the traceability of seed and food value chain. And I would like to also add a few points that why really it is important to do this exercise. The information on this benchmarking, what all have said and what I have said, and tracking the progress would not only help the government to prioritize their actions toward the system, the desirable food system transformation, because food system transformation is happening already, but it will also help the build the evidence-based narrative and demand from the consumer side, actually, from the industry to follow the practices and the supply of product which aligns with the goals of food system transformation. And in fact, this will be also important to for the multilateral institutions and agreement to get informed that their actions are also whether aligns with the food system transformation or not. So there's a real need of monitoring. And actually, as on today, whatever in few pockets and few segments, the efforts are being done, but I think it's not enough. And going forward, there's a need for the greater interaction among the expert academia with the government and private sector to integrate this monitoring at different stages of the food value chain and systems through increasingly using the real-time digital tools probably and involving more and more communities, probably the crowdsourcing information. So I will stop here. Thank you.
Sure. So you bring not just the role of different stakeholders, but the layers and levels of data from farm level long-term studies to consumers and understanding what policymakers want. Yeah, so how do we bring all this together? I guess that's one of the challenges that the Alliance has set out to do, to bring together the collection of institutions that are able to work together to achieve it. Thank you so much. Kenneth, can we move on to you? So Kenneth Stresbeck is from the Massachusetts Institute of Technology. He has spent 30 years as a researcher and practitioner at the nexus of engineering, environmental, and economic systems. His work is primarily related to water resource planning and management, river basin planning and modeling of agricultural environment and water resources systems. He's worked in operations research, engineering economics, microeconomics, and environmental economics in various applications. We look forward to hearing what you lay for us as your foundational comments. Thank you, Kenneth.
Thank you, and good afternoon and good morning to everyone here. I want to follow up on the wonderful comments of Maximo and my three other co-panelists, and just want to take a little bit higher perspective on, as we look at data and as we look at modeling and evaluation, the whole point of doing modeling and data gathering is to try to take our data that we're getting and bringing it to insight so we can make policy. And we've heard about a whole host of different indicators that people have talked about. And one thing I want to bring up is that one of the things that happens is, and as we've seen as we move forward, is what I call is the informality in many of our works related to indices and indicators, where a general thing is an indicator is usually something we measure. Along here is an example of a Bay Health indicator, which has things that we can actually sample from the world, water clarity, et cetera. We then bring those into indices, and then those can be combined. And many times there is a lot of not bias, maybe we bring biases to that, but there is not a lot of research done on how do we properly go from indicators to indices. And the indices become very important in ranking things, allocating resources. And the same thing can happen in food systems or nutrition systems, anything we do. So I think we have to take a better look at how we're getting these indices. And I have many examples from water where a number was in one paper 30 years ago, and that is a legacy number. And does it mean the same thing as we move forward? The other thing as we look is the next idea of combining indices. And as we look at climate systems, coming up with things like a climate moisture index, which is looking at the whole nature. And this is important as we look at food systems and irrigation and cropping. It's how do things move in combination? And that an indicator of just precipitation does not mean anything unless we understand what's happening in potential evapotranspiration or crop water needs. So we say something's wetting or drying, that's a relative term related to its demand for water. And we have to look at that together as we move forward here. Then the other thing is sometimes things are collections of indices. And how do we do that? Like the Human Development Index, or particularly over here, when you see the Healthy Eating Index. Here are these points that were assigned by somebody, and then there's a standard. Where did that come from? And many times you try to find, where is the data in the literature for that? And then people will use this upon this, and we have this growing uncertainty in our numbers because of we want to do something good, but there's not the background to it. The other big thing I want to talk about is uncertainty. And particularly this is if we look at climate change. This is an example of the range of annual precipitation changes from a series of modeling runs on the Volta River. And if we look at the black dots, and particularly in the first three scenarios, there's no change. So if you report that there's no change, but what we see, we have as a box and whisker plot here, we see 50% of that distribution is significantly range from there. So we have 25% and 50% probabilities of being very far from that number. And we know in climate systems that we are in food systems, we're not linear. So extreme wet or extreme dry, and we have this issue of the floor of the averages. So the average impact is not the dot in the middle of those two extremes, it's something way off. And so we have to be looking at how we deal with uncertainties. And the other thing is we look into spatial and temporal variability. So much of what we do is related to risk. As we look at global change, climate's changing, economy's changing, society's changing, and trying to understand when we come with indicators, are we dealing with measures of the extremes or the tails, and how do we deal with risk? And this is just an example of codification of what can be happening. Means changing, variances changing, and we heard it way before in a couple of our discussions. This whole idea of the changing of variability for food systems and water systems, very, very important, and particularly the natures of drought, multi-year drought, interseasonal droughts. How do we measure those in our work? And then finally, something that can happen quite a bit is how do we aggregate spatially? So this is a map of water stress in the world, and we look at the United States here, and it looks great, nice and blue, happy to be there. But then if you look at an example of diving into the US and looking at water stress, you can't average the United States. The eastern side is very wet, the western side is very dry, and you can't bring that water together, although some wild and crazy engineers want to do that and build big pipelines, just like in South Africa, we want to bring water from the Congo down to Hartang. So we can do it as engineers, but it takes a lot of energy, and I don't think it's good for the environment. But anyways, these are some of the things that I've seen in the last 30 years in trying to work with global models, working with policy is, I think we have to be a little bit more careful with our indicators, what they mean, what are indicators, what are indices, and what is the veracity behind those as we move forward, and just think about it together as a community. I don't have the answer. It's something that dogs me all the time, but eventually it's all about the data, whether that data is collected from the field or the data is generated by models or stakeholder meetings. Does that data limit the insights and the policy we can make? And do we start to need, as part of the Alliance, an initiative on data to be parsimonious to the right level for the questions we're asking? Thank you.
Great. So you've challenged quite a few components, and they've created a lovely platform for especially the breakaway groups to discuss. So some of the things I picked up was the need for common terminology, so we're clear on what we're actually talking about, and the validation of some of these indexes and how we bring them together. I think it relates again to what Shalandra spoke about the range of different components, and then Nicole's the disparities between social and the more scientific components. So you each bring a really important contribution to setting the scene for understanding, and also bringing an understanding of what we're starting with and what kind of information we have. If you were to identify the biggest gap in your field as it relates to food systems, what would that be? Any order? You don't have to speak in the same order. Please just unmute and go ahead. What is the biggest gap in your knowledge that prevents progress in food systems monitoring and evaluation? Shalandra?
Yeah. So it's a very big topic which you are asking, but I will only put three points here. But all these three in the context that any data or the monitoring we are doing, first of all, it has to be at the local systems and regional systems and global systems, because as just now, Kane has shown how it is important. But the 3 points which I would like to prioritize under the current food systems is the carbon and natural resource footprints, and also the other hazardous elements in terms of chemicals and plastic across the different value chain stages, the kind of food systems we are kind of developing, and quantifying their multidimensional impacts on the overall well-being and health of the people. This is one, and which is not really happening at the system level. The second one is the impact of technology and policies or particular market interventions. On the social side, the equity aspect, the health dimension, the natural resources, and also especially the riskiness of the production systems, but also the livelihood, especially for the vulnerable people and considering the gender dimension. The third point, I would say that there is not sufficient information available on the trade-offs when we talk about the conventional agri production systems or food system versus the agroecological intensifications, which should also consider the quality of food, because there's a lot of debate and kind of there is no convergence. So these three, I would say, are really important if we want to move forward in the desired direction. Thank you.
Great, thank you. Anybody want to follow on from that?
Okay.
Sure,
I'll
go ahead.
Yes, I would say that the biggest thing for me is false precision. We have developed for us, particularly, and we love Esri and GIS, but the ability now to mathematically disaggregate point data, I think is almost tragic, because I can go find a map produced in the journals now of a 1 kilometer food index developed by crops being grown on soils all down to 1 kilometer, which was based on data maybe 100 kilometers or 10 kilometers. But the lack of understanding about the veracity of the data being used, we're using it to make micro scale decisions. And I think it's valuable tool, but to use its horses for courses. I think we need to be much more careful in downscaling global data. And we can, in the climate world, taking 1 degree by 1 degree projections and using mathematics, not even climate science, to bring them to kilometer by kilometer, and people are using them. And then also the use of linear lines in climate data, where we look at 2050 or a linear line when the whole thing's about variability. So I call it false precision. It's there and it's important for global issues, but we can't get away from local data collection in every area.
Okay, thank you. Thank you.
Maybe if I can add there, I really like Shalanda's points around the internalizing the typical external costs, the local benefits versus, or the local impacts versus the global benefits due to, well, all number of global trade. So I really just don't want to say my point is more important. I just want to support that. I think that's a really important one. Just want to bring something else to monitoring and evaluation. It's one even if we have from an excellent indicator with a required precision supported by the appropriate disciplinary knowledge that can track a particular food system transition, there still remains the issue of whose indicator is it and who defined the indicator. So there's this notion of worldviews, who has, and the perception of, I mean, if we can all look at the same wheat field, and a baker would go, great bread, agronomist would go, great, the rows are straight. A biodiversity person might say, this is a disaster, it's only one species, and you get my drift. So that also translates into an indicator, what we think is good, what we think is bad, what we want, what we don't want. It doesn't make it easier, but I think it's a dimension easily overlooked in this data-rich environment. Thank you.
Sure, and how we get the dialogue to make sure we understand each other from different disciplinary perspectives. Yeah, great, Nicole.
Yeah, and I can add to that. So, who decides the indicators ultimately, in a way, we're talking about power and major power imbalances in food systems. And so when we discuss transformation of any sort, that really needs to be at a center from my perspective. And one example of an evidence gap that really speaks to imbalances in power is in the social space, looking at labor conditions in food supply chain. So we have very little data on forced labor, child labor, wage conditions, freedom from harassment, et cetera, at any level, Kenneth mentioned local level, but we don't have that data at lots of different levels. And so it's interesting because a lot of company practice in this space is based on social audits, and a small number of organizations do that, and they can be quite good, but some can be quite flawed, and the data aren't disclosed to the public. So we need to think critically about ways to develop more robust data sets, especially in these contexts where there is an extreme imbalance in power. So in the labor space, right, there are startups developing or NGOs developing app-based tools where workers can report issues with their working conditions. There are worker-driven social responsibility models like those used by the Coalition of Immokalee Workers and Migrant Justice in the US, where they've designed a monitoring and auditing system very differently than would be typical in most supply chains that has improved, reporting, accountability, transparency. But it's a really big issue in the social space. How do we address these power imbalances to get good data? Because otherwise things are just invisible. And when we, no data doesn't mean no issues, right? So that's something that keeps me up at night sometimes.
So do you have a solution? Because my last round of questions relates to how do we overcome this? How do we develop more systematic M&E systems? Do you have an idea, Nicole, in the area of labor?
Yeah, so I think the app-based tools that are held by third parties, it's an interesting model where, the workers are sort of the agents, the reporters of risk or conditions versus an external party coming in and, the employer getting a heads up ahead of time and things look really nice at the audit stage. So that's one idea. And then just other ways of constructing those systems where, CIW or Coalition of Immokalee Workers has a third party that's run by a nonprofit where the workers report directly to the nonprofit, and there's accountability with the employers as well. They've sort of designed a different system that doesn't necessarily get us better data, but it gets us better outcomes. So I think those are two different models, one for data and one just for results in supply chains. Yeah.
Okay, great. Anyone else? Byron, Shalenda, you come from the global south. We face unique problems in this area as well. Shalendra?
Yeah, so one is I will talk more of in the context of how, because I myself and others have mentioned a number of things which needs to be done. And I see this question in the context of how this alliance can play a role. And before I go to that question, I want to mention one thing, that the whole process of this indicators, wherever there's no direct indicators, difficult to decide, I think it has to be a lot of stakeholder driven process. And because this food system transformation, when we are talking about, people are most important here. And people means not only consumers, but various stakeholders. So if you really want to build good indicators, then it has to be the really robust and strong stakeholder driven process to identify those indicators. This is one point I wanted to mention. But the other point to the question you asked, which I will talk in the sense of alliance, will not really give a specific example, but I would say that there is a really need. As of now, there is some monitoring in parts and some pieces, and somewhere it is there, but there is no real proper the system-wide monitoring happening, which makes kind of pressure, or which creates pressure on the stakeholder to do that monitoring. That kind of narrative is not there. So I think first of all, the major objective maybe for this alliance and others who are working in the same space or same objective, there's a need to build an evidence-based narrative so that it results into it becomes a requirement of all the food value chain or food system actors to generate and record and provide that kind of data in a transparent manner. Maybe either
Right.
whether the private companies or the government and whosoever is in the part of the food system.
Right.
So it becomes imperative for them. And just one more point I want to say that, but we need to create like incentive and disincentive to promote this kind of process, and maybe using various modern tools, including digital technologies and crowdsourcing. And I want to mention again that need to really generate a lot of information on trade-offs on the agroecological intensification and the conventional approaches to really move forward which direction we should move. Yeah, thank you.
Great, thank you.
I think I'd like to add one thing is part of the issue is if we're dealing with this false precision and others is so much of the data is in the academic world and they're generated in the academic world. And to do these other things are not really new science, and the whole tenure process and others are what are you doing? Well, I'm just making somebody else's data better is not as interesting or attractive. So how do we change the incentives for doing that kind of work? How do we provide it? Is it something like the community that's on the call right now, hiring firms? There are so many good firms that we know that take science for industry or defense or government purposes, and they're not publishing, and people live in that world. Maybe we need to push it to that world, or have a part of the community which is providing the data that we need. And that, you know, we have a dean on the call, we have a department chair. How do we help them get tenure if they're doing that without it being second-rate science, when it may be first-rate science to make this creative? So I think the transformation is in our funding and how we move forward.
Which comes back to you wearing your dean's hat. How do we make it happen? Do you want the last word, Prof. Erasmus?
I think I'd like, as I listen to Kenneth, I think there's a lot of parallels to be drawn to where the climate change community was 10 to 15 years ago. I'm paraphrasing quite a bit, and if there's people here with other experiences from the climate change science and impacts community, please contribute. But certainly my view is that for the action on climate change only started getting traction when scientists move away from reporting millimeters of rain in degrees Celsius. Not that those are not important, but there's something in between, and different people call it different things. I call it an impact model, so that I can tell a large logistics company that the increase in thunderstorms is going to mean that your planes will be later by 30 minutes, and therefore just-in-time manufacturing for a car manufacturer will make your car 10% more expensive. Once you start making those links, then all of a sudden climate change has got traction. The double-edged sword of that, though, is that that's quite detailed. Those impact models need a lot of domain-specific knowledge and need a lot of tailor-making. But the climate change community, arguably, depending on where you are in the world, have gotten some of this traction. I mean, the large logistics companies now do this. Oceanic, land, air, and so on. So I think there's hope. We can learn from it. So
great, thank you. An inspiring note to end on as we move into the group discussions. Thank you so much, panelists, for your wonderful contributions to the discussions. And I'll go back to Cassidy. You're going to explain the group process. Thank you, everyone.
I can take care of that. I just wanted to actually follow
on
to Baron's last point on this. You know, I think what we've learned from kind of this discussion is with regard to climate change, food systems make energy systems look simple, right? I mean, the transitions we need, the monitoring evaluation we need to build transformation in food systems is far more complex, and it really is. I mean, it comes down to individual, you know, over 7 billion individual people making choices every day. So we've got our work cut out for us. We're going to break off into breakout sessions now. I believe we've got 4, and you will be auto-assigned to these, and they'll be facilitated by some of us here. And I'm just going to put this out there now, and hopefully every facilitator brings us up to first task of every breakout session is to establish who will be the note taker who will report back out to the group at the end, because we cannot record the breakout sessions, unfortunately. So you will find yourself sent off to a breakout room momentarily, and we will reconvene in a little under an hour to report back out.
It looks like we're the first back.
We jumped before we were pushed.
Sometimes it's better because you get pushed out.
Yeah.
But it's so exciting to see science talked about this week.
Mhm.
Well, I thank you, everyone. I hope that your breakout sessions were as interesting as ours was. We are nearing the end of our side event today. So what we'll do now is ask each group to report back from the breakout rooms, kind of what some of the key takeaways were. Hopefully you all had a note taker and reporter. Are you all aware of what your group numbers were? Hopefully, okay. Cassidy, you want to pop in here on this? If we can have a list, or
I am not aware, admittedly, of my breakout group room number, but I think we can just go by the facilitator of each room and have them turn it over to the reporter.
All right. Would you mind calling out the facilitators?
Sure. Cheryl, would you in your group be able to go first?
Yes, sure. So we were group 4, Nicole, but Nicole's going to report back for us. Thank you.
Sure. So I will be quick, and Cassidy, I will plan on sending detailed notes to you all, because I'm not going to capture the diversity of issues we discussed in our conversation. So a few big themes on evidence gaps. So being able to harness big and diverse data responsibly. So Pete had shared, from a climate modeling perspective, we're swimming in data and we need to figure out how to discern among data sets, to manage them and to harness big data. So thinking from a research perspective, we need expertise from folks like in the discipline of bioinformatics and related disciplines on our food systems research team so that we have that competency embedded. Similarly, discussion of, how do we collect and aggregate data from diverse stakeholders in the space? So, NGOs, governments, different stakeholders working in particular contexts are already collecting some great data, but we need protocols for data sharing. We need, ways of working together, building that trust, et cetera. The other data comment I'll make is this idea of, scalable data and standardization. So we, in a lot of our work, we have, data set X and data set Y, and they're at different resolutions that are mismatched. So how do we sort of harmonize across different data sets, especially when we're maybe working in different domains of sustainability, which is even stickier wicket to deal with, but how do we make data speak to each other? It's a really big gap that we need to address in this space. For the second question around expertise, we talked about who counts as an expert. So institutions like universities, think tanks, UN, FAO regional offices, also natural scientists. We discussed how the sort of knowledge and expertise of natural scientists tends to be valued more in this space than social scientists. And that led us to identify a need for more social scientists on these teams for multiple reasons. So, integrating citizen science can help ID when generalization and scaling up data makes sense, and when that leads to really terrible interpretations that actually don't do us any good. So we discussed, this need for more collaboration in that space, more, mobilization of funding to ensure that the social science research is a valued piece of the puzzle when we do this kind of work. And the other kind of missing piece of expertise we discussed was local expertise that needs to be valued, particularly of Indigenous peoples and other folks on the ground who are most affected by or could benefit by research that we're doing on M&E. So we need participatory and inclusive methods. We talked about gender inclusive methods to be able to work in that space and ensure that folks who are normally excluded from these types of or often excluded from these types of conversations, that their knowledge is valued and represented as we're doing M&E type work.
Thank you.
Thank you so much, Nicole.
Very lively conversation. Sorry, Cassidy, go ahead.
Thanks, Nicole. Let's go to Shalander in your group next.
First, from our group is Tim Thomas. Tim, please, over to you.
Thank you very much. Well, we had a wide-ranging discussion as well. We started off, Shalander challenged us on the planetary boundary side of thing, and also had in mind sort of along the lines, I think, of the Eat Lancet report, where nutrition and planetary boundaries are both taken into consideration in regard to a sustainable food system. So some of our conversation went around there, and I think one of the earlier points was that the trouble is it's easier to monitor something that is close to where it's supposed to be than to monitor something that is far from where it's supposed to be. So that creates challenges. But also some of the points were that, well, there are monitoring and evaluation systems already in place, and we shouldn't overlook what's already there. And that not just are they there, but there are all sorts of governmental and NGO structures that are available and are really part of the food system and active in the food system that can be brought into this whole idea of monitoring and evaluation. And also in that regard, the idea of prices and the fact that right now there's monitoring of prices in various places on the side of food security. So that one of the challenges though would be to expand the commodities monitored, because if you're starting to talk about a nutritious, food basket, then you have to start monitoring more fruits and veggies and nuts and maybe meats and a whole bigger basket of commodities that's important if you're expanding beyond simple calorie intake. So then we looked on the nutrition side, and current monitoring is largely related to weight versus height or simple surveys about how many meals did you eat today, or how, did anybody in your family go to bed hungry this week, things like that. But when we're talking nutrition and we have goals of full nutrition, then you have to start monitoring things like protein intake and micronutrient intake. And so that creates all sorts of challenges for monitoring. And so those are things that can be dealt with, but it's complicated. It's not an easy sort of thing. We also talked about the whole production side of things. When you're talking planetary boundaries of things like biodiversity, water, nitrogen, phosphorus, and we never came up with a fifth one, but there's another one affected by agriculture. Those are not currently well monitored. At least some of them are not currently well monitored. And so there would need to be improvement in those areas. We also brought up the topic of food safety, and that in a lot of countries, the whole food safety monitoring system is not well developed at all. And one thing that we should have brought up, but we didn't, is the whole idea of looking at the issues of transportation and processing, because some of those broke down during COVID as well. And things like one thing I have modeled and looked at, and not very well modeled, I might say, is that by 2021, the projection for sub-Saharan Africa is to have 4 billion people. And that's 4 times what there is now. And the question is, if Africa is not meeting its own nutritional needs by producing enough food, there's going to have to be importation, and that really could potentially stress the transportation network by quite a bit.
Tim,
so
thank you so much. I'm afraid I'm going to have to cut you off just because
Yeah,
we're running short on time.
So
Oh, perfect timing. Thank you so much. And if you have any more detailed notes, you're welcome to share them with me directly so we can incorporate. I'm going to turn it over to Kenneth now from our breakout group.
Great. I just want to be brief and say we've covered many of the things that were already spoken about, but the 2 key things that came out of our group that are unique is the gap in bringing indigenous information to the transformation system. How do we do that in what Albert has called Edu-Indo science, which is the educational of indigenous science, and how do we bring that and translate that information to be scientifically useful for the hybrid of as we go forward. But working with that, the other one was there's a lack of the same sort of data we have for livestock. We have lots on crops, but livestock is dragging, particularly in Africa, in phenotypes, and it's very expensive to move that forward. And then finally, as remote sensing is a very important tool, but we have to deal with the issues of technology and of the cost, and getting that into the hands of the people that need it and working on that as a public good. So with that, I thank my group, and that was only a touch of what the great things we talked about.
Thank you so much. And last but not least is Greg's group.
Great, thank you. Estee will be reporting out our groups.
Right, so for the first question with regard to the evidence gaps, we also noted the scale, the differences on how do you formulate a single frame reference, the issues of different criteria and scale for smallholder versus commercial farming, lack of standards for data resources. This was also mentioned by the other groups, so more standardized definitions and unified methodology required. With regard to question 2 on the need for systemic food systems monitoring processes, again was raised the indicators for various drivers should be set within countries, and that there are not well-established links among the drivers in the value chain. So we need some monitoring to link these. Important to rely on data that's already available by applying and understanding trends from global data which is available. Production can be measured and the decision makers must be aware of what is already available. With regard to the metrics and equity, at the moment, production dominates. So demographics are often not considered. The impact of population growth and demand gets overlooked in monitoring systems. And this is against the background of climatic stresses. There was also the mention on what perspectives might be missing, and we also noted the participatory approach, which is required, a larger inclusion of stakeholders, understanding the levels of the drivers so that we can understand how to monitor and how these drivers may be nested. It was mentioned the power relations as previously with exclusion, the danger of exclusion of certain groups. And then also with regard to putting these systems in place, the locus is often with governance who controls, which will also influence how the system can be monitored. And then with nutritional metrics, we are looking a lot at the carbon within the production system, but not so much as in the consumption. And lastly, also, we need frameworks for mapping the inequalities when some of these new products or organic farming or new variants are produced, so that how do we monitor those products and make sure that it's equally distributed. And I think the detailed notes I've sent to Greg. Thanks.
Thank you so much. I'll turn it over to Greg with our last minute here to close this out then.
Yeah, I think today was a very interesting, productive day. We had all the discussions, both public and the breakout ones were, I thought, very engaging and I think very valuable and for informing the UN Food Systems Summit process. I just want to thank you all for taking the time out of your day to participate and for giving your input to this process as well. We also, with regard to the Alliance, our plan is to officially launch the Alliance right around the UN Food Systems Summit. So look for more coming from us and look forward to hopefully seeing and engaging with many of you in the future. Thank you very much.